Okay, good morning, ladies and gentlemen. How are you out there? Are you having fun yet? Oh, you are? Oh, I'll go away then. It is a pleasure and a privilege to be standing in front of you once again at Security. Some of you will know, if you are kind of old Security hands, that what happens is about 2 weeks before Security, some speaker drops out. The committee go, panic! And I get an email saying, Ian, would you mind just presenting something for an hour? All right, okay. So I'm Chief Deputy Underdog Reserve Emergency Speaker. I think is my official title as far as Security goes. So here I am to try and entertain you. I have to say, this is a completely novel experience, standing here at 11 o'clock in the morning. Because I always get put on the 4 o'clock slot in the afternoon because I'm the emergency reserve guy. And everybody just wants to go to the pub. So I've actually got a genuine chance to blow the arse off you for an hour this morning while there's some attention going here. Why not? For those of you who don't know me, my name is Ian Ferguson. I'm actually one of the staffers here at Applicability, or a life resident or a life sentence or something at Applicability. I've been here for nearly 13 years now, would you believe? I've also been teaching digital forensics since I think about 2004 and had the awful experience in the digital forensics class this year of realising that some of the slides in my deck were older than the people I was talking to, which kind of terrified me, but there we go. Shall we do some technical stuff? Shall we talk technology and some interesting things? I would like to talk to you essentially about a real digital forensics case that I got involved in a couple of years ago. I teach digital forensics here for folks who don't know me. I occasionally get to do real casework, both on the defence side and occasionally Police Scotland come along and knock on the door and say, could you help out with something? This was one of those occasions. It's never made it into any of my official teachings. I thought, yeah, why not talk about it today and see if we can interest people in this. So the title is Samsung plus Regex equals heat. And what you're about to see is the story of a real investigation involving Samsung mobile phone. So if you wanted something to take away from here, we'll do the takeaway, we'll do the summary right at the beginning. What we did was we managed to identify a new source of interesting information, on Android mobile phones. In particular, a file called ssrm_heating.log, which doesn't sound terribly exciting when you say it like that, but you'll see it actually had quite profound consequences for the case that I was involved with. Basically, what we're going to talk about is the fact that I needed to search a great big forensic image from a mobile phone for timestamps. Sounds pretty routine, mundane, the kind of thing that we do teach in CMP 209. Turned out it wasn't quite as easy as you might have thought, and we had to do some jiggery-pokery to make it work. In particular, that's Clay host. Let's get this the technology here. I had to develop a new version of grep, which I'm sure you've all heard of, called BiGrep, to work with this. Ordinary grep wouldn't cut it. I think it's quite interesting why that had to be done and how it was done. We then looked at turning a one-off investigation and a one-off find of something into a proper digital forensics methodology, and to see why that might be an interesting task. One of the things we were concerned with was how widely it was applicable, and we'll talk a little bit about that as well. So that's the roadmap for the next hour or so. Some kudos to other people. I'm glad to see that Ethan is back with us this morning. He was my partner in crime, literally. That's a good joke. I'll remember to put that one in again. On this, Michael, are you here by any chance? Michael Kleinman was a student that we had working for us over the summer on this one played. And also Lindsay, without whose valuable input and knowledge we wouldn't have got as far as we did. So well done to them, thank you. Okay, motivation, story time. 2019. Is it really that long ago? Ordinary day in the office, sitting upstairs, get a phone call from reception at the front desk. Police Scotland are here to see you. Damn, they finally caught me. Went down. A fella that I know, DCI Mark Lorente. Do we have any Police Scotland folk in this morning? No. Say what I like about it. Good. So basically, we've got this case that we're working on. It's a rape case, and the defendant's defence effectively is that he couldn't have been raping somebody at that time because that somebody was actually playing a game on their mobile phone. That was the defence. All right, so what it actually boiled down to was, could we establish whether this particular game, a thing called Toy Blast, by an outfit called Peak Games, had it been played on a particular mobile phone at a certain period? If it had been, he had an alibi. If it hadn't been, then it wasn't looking too good for him. Now, interestingly, the victim actually volunteered her mobile phone. Said, you may examine that. And they've given it to, this was the folks along, it was here in Dundee, along at Bell Street Police Station, just along the street there. They'd taken her phone and they'd done a kind of full forensic number on it. So they'd imaged it. Of course, they had the passcode, so there was nothing particularly exciting about the imaging bit of this, of it being encrypted or any of that kind of jazz. So there's no interesting stories about cracking encryption with PlayStation 3s or anything like in this one. They'd got a hold of an image of this thing, and they'd run it through all of the current generation of digital forensics tools. If you're in this game, you will know X-Ray, you'll know Celebrite, you may have heard of Grey Key and this kind of thing. They'd run it through that, and it could produce absolutely nothing about said mobile phone, about this particular game, or about this particular time. So they sent it down to the folks in Edinburgh, at the top secret digital forensics facility just outside the airport, with a burger van outside it, where you see all the coppers queuing up at lunchtime, so you know exactly which building is the top secret facility. They couldn't do anything on it. They sent it down to the Metropolitan Police in London. Could they dig any evidence out of this phone that game had been played during the actual 20 minutes that were relevant to the case? And it came back, nothing, can't do it. I think I'm pleased to be kind of the third person in the queue that they called. So, person of last resort. They can't do anything with it. Give it to Fergie, see if he can have a go at it. Right? Okay. So they gave us a 32 gigabyte forensic image of the phone, the entire storage of the phone. They gave us some details of the time period of interest, and they gave us an accidental screenshot. Maybe you don't do it. Maybe young people don't do this. But my phone is absolutely full of screenshots where I've accidentally pulled it out of my pocket and gone, click, and screenshot the damn thing. They found an accidental screenshot of round about the right period showing a picture of this game. All right, okay, that's something to go on. So there's quite a lot riding on this, but it was very much if you can find something, you can. If you can't, don't worry too much about it. We tried, and you are the last resort. All right. So I had a go, and we tried various things. We thought, well, there's be some network logs on the device. It's a game. It's bound to be shipping high scores back to the mothership somewhere. Can we see any evidence that it's done that? Is there a log file somewhere which tells us this phone's been communicating? No. All right. Let's get the boys at Bell Street to get in touch with the ISP. I can't honestly remember whether it was O2, who the hell it was, Virgin. Have you got the logs for that phone? Is there any evidence of what was being sent over the network on that phone at that particular time? Came back blank. Can't remember whether it was we don't have any logs or there was nothing for that time, but it came back blank anyway. All right, getting a bit desperate. We know who the game maker is. Let's footprint them. So we did the full footprinting number, trying to find a little bit about them, who they are, where they are. Turns out they're in Turkey, I think. Let's get in touch with them. Have you got anything? Is there anything in your system logs which will tell us what that phone was doing at that time? No reply. Nothing. Zip. No. I think somebody did try and get the Turkish police to go and knock on their door. I don't think that ever happened. Whatever. All right, we know the name of the game. We know a little bit about making games around here at Abate, allegedly. Incidentally, we're all in the wrong game, by the way. We should have all gone and done computer games instead of computer security. When we looked into this bloody game and saw what people were paying for a few fancy graphics and some crap code, people are being paid good money to churn this stuff out. Awful. Basically, we tried to reverse engineer the game. Could we figure out anything going on there? At this stage, we're starting to get a little suspicious. This game actually isn't communicating with anything at all. It's a standalone game on a phone. There is no communication. There's nothing in the log. There's nothing. We've got nothing. The whole assumption that the thing connected back to the mothership and we could find something that way, false. As far as I know, I didn't kind of go ahead and prove that, but that was our working assumption disproved. What else are we going to do? All right. And this is kind of the point of the talk. Digital forensics isn't just about using the tools and pressing the buttons and seeing the pretty stuff that comes back. If you can't find, was the game being played at that time, try asking a different question. At that time, was the game being played? Now that sounds silly and trite, I know, but I can actually remember sitting there at kind of the moment that my thought flipped over. Right, stop looking at it that way. Look at it the other way. Can you find anything at all on the phone which tells you what was going on at that time period? Oh, how would I do that? Well, we've got all of this stuff back from the other forensic tools that have been done on it. They're finding nothing relevant. What would happen if I searched the entire binary image for timestamps relevant to the 20 minutes where this crime is alleged to have taken place? One point, how can I do that? Well, we can come up with time pretty easy. We know what it looks like. How do you actually search for that? None of these forensic tools have pulled it out. What are we going to do? In other words, how do you search for timestamps? At this point, again, this is kind of one of the point of the talks, that you really do need to know the fundamentals of what's going on in a system. What do timestamps look like? Well, actually, there's lots of different possible formats of timestamps, and we looked at several. SQLite, as I'm sure you know, is a database which is widely used by Android and, in fact, by Apple iOS as well. What would a timestamp in those periods look like in SQLite format? Text. It's actually moderately easy to search for. Not all programs. We're being hacked. Someone is breaking me. Why is it always me? Whenever I stand in this bloody lecture. I don't think I've actually spoken in this lecture theatre for about 3 years because of COVID and blah, 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 blah. So it's a bit weird being back, but every time I'm in it. You will know that timestamps are often stored just as a dirty great big integer, and that integer is often the number of seconds since the 1st of January 1970, or the number of milliseconds since the 1st of January 1970. The Unix epoch. Oh my God, I'm older than the Unix epoch. You can't measure me with Unix. There are some variations to that. You don't know whether the timestamp is going to represent UTC, Universal Time Code, Greenwich Mean Time. Could have been British Summertime. Was it? Well, actually not in December, so that made that one a little bit easier. Was it actually even in local time? Was it some other time zone? All right, so this is starting to get a little bit complicated. What might that timestamp actually look like? Well, I'm going to search using grep. If I want to specify how to find anything on a computer, I'm probably going to use a regular expression. All right, what does 10 a.m. on the particular day in question look like? Well, if it was a local time, then it looks a lot like that in milliseconds. If it's GMT, it's an hour earlier. It looks a lot like... It's a number. Okay. All right, well, that's just an integer. Remember CMP 101, some of you, from years ago? Data representation and all of that jazz? Well, let's try and represent that as hex. Turns out that it comes out like that. It's a hexadecimal integer. Okay. We knew that the incident, I think it was 1040, let's call it 1040, between 1040 and 11 for sake of argument. We thought we'd kind of change the range a bit, so we went for anything between 10 a.m. and 1 p.m, and we worked out what the hex representation of those integers was for those two times. So we have bounds that we're looking for, right? Now, hang on. Timestamps. Long in C, yes, right. So a 64-bit integer. I need to pad these things, and actually what I need to do is to ignore the least significant byte. And that's going to give me a time range corresponding to the start and the end. So we're just ignoring, I can't remember how much of it we ignored, but depending on how many bits you ignore, you're kind of giving yourself a different range of times that you're looking for. It needs to be encoded and escaped for the shell and for big grep. Turns out we were searching for that as our regular expression. I think that's 10 o'clock. All right. Well, actually 10 o'clock, and if you remember your regular expressions, on the end, the dot means I don't care what's in there. So it's 10 o'clock and a bit. So I'm searching this whole binary image for things representing the time 10 o'clock and a bit to 1 o'clock and a bit less. Okay. Just say we're going to search a 32 gigabyte image. We've got a copy of the entire memory of the phone. There's a problem with that, and I don't think I'd ever worked it out until I came to this case. grep, our friendly command line grep that we've all used and some of us use every day, is profoundly meant for searching for things in text files. In other words, it's meant for searching for printable characters. It's meant for searching with things which have a return on the end which say, that's the end of the line. Hang on, that 32 gigabyte file is profoundly, it's binary data. It doesn't correspond to that. grep has a 2K line length limit. 2048, a big surprise. Can't use grep to do this. All right, okay, that's a bit of a problem. Also, turns out there's no way of having non-printable characters in the regex. Actually, I've since found out there are some flavors of grep do that, but at the time that we profoundly believed that we could not use regex with non-printable chars. And then the real big one is that grep has been compiled, and this is true for almost all of the versions that you see out there, with 32-bit file pointers. In other words, the maximum size file you can search with grep is 4 and a bit gigabytes. Right, that's just blown our approach out the water. We can't go grepping for timestamps. What do? Do we run away and cry quietly in a corner? Admit failure? Walk along the Bell Street police station and say, alas, I can do nothing? No, we are software engineers, we are hackers, we are headbangers, we rewrote grep. We did. This is the best bit. We're coming to the best bit. When you see how long it takes to rewrite grep, you're either going to call me a charlatan or God. Right. I rewrote a thing called, well, I call it by grep. It could be big grep, could be by grep, who cares? I used Python. I used a library called mmap, memory management library, memory mapping library, and I'm going to tell you how marvellous that is in a second. And good old regex library, the standard regex library for Python. Python is more modern than Java. Python has 64-bit file pointers, so we've just blown that objection to Java straight out of the water. We want to allow the specification of the pattern as hex, so I need some way of processing the command line to do that. Big deal, we can write command line processors. It's available there. If you wait till the last slide, there's a nice QR code, and you can go straight to the page if you wish to download this pile of useful code. And actually, this is where you're going to cry. That's it. It's only 4 lines. Seriously, you can implement grep in 4 lines. Yeah, you can in Python. Actually, it's not. Okay, there's about 12 lines before that, which take the parameters from the command line and process them so that they're in a nice form to use it. Those 4 lines are the only 4 lines that do anything useful in that program. What does it do? It takes the name of the file that you've typed in, one that you want to search. It memory maps it. So there's a kind of a virtual memory thing going on here. Basically what it means is you can treat the entire file as one big string. Python thinks it's a string. And mmap is hiding the fact that it isn't even in RAM, the fact that it's on disk. It doesn't try and load it all at once, so it doesn't matter if you haven't got 32 gigs of RAM on your machine. mmap handles it. Kudos to the designers of mmap. This is one of the nicest, most powerful abstractions I have ever used in my career. It is genius. Okay, so we now have the data sitting in variable. We take the pattern, what we want to search for. Well, all that's doing is grabbing it from the args array, from the command line arguments for the program. We're then going to say, I want an iterator which looks for that pattern in that data, and then for every match that it finds, print me out the match. That's it. grep re-implemented. 4 lines of Python. Brilliant. Not my brilliance, Python's brilliance. Okay, back to the story. What did it do when we ran this thing? Well, it actually produced exactly that output there. So we're searching a 32 gigabyte file, and it gave me a dozen lines. All right. A lot of them text files. Well, yes, I have an advanced forensic tool called Notepad, which we use to have a quick look at text files. Nothing very interesting. There's a whole load of DB files. SQLite DB, all over Android. Yeah, had a look at those of SQLite. Nothing terribly interesting. How's this one? SSRM heating.log. Never heard of that before. Ooh. Right. So what we did, we actually grepped through all of these. This was kind of before I even went to SQLite. Looked for a bunch of words that might be associated with the particular game. So we looked for Peak Games, which was the name of the manufacturer. We looked for the name of the game. We looked for one or other 2 things. What did it turn out? Now, I apologise that this is down the bottom here, but we found that as a log entry. So 11:49 timing. What's the biggest asset of a comedian? Timing. No, you didn't get that one, did you? Right. Timestamp. It matches. Remember, we were thinking about it being an hour out because of BST and GMT. Top. Peak Games. All right. Well, top. Hang on. Top. That's a Unix command. This is Android. All right. So actually, this thing was something called net.peakgames.amy, was using 12.8% of something. Surface Flinger, 2.82%. Audio Server, 2.2%. The game's running at that time. It's doing something. We found that it's using resources. Okay. At that moment, we now know we're onto something. There is something being logged here. We better have a bit deeper look at this SSRM heating log. So it's the only one that matches the timestamp and the strings connected to the game. And we came up with a whole bunch of log entries, PMP entries, COM entries, net entries, top entries, no idea what they are. I've never seen this before in my life either. This is completely new to me. We've got some stuff which appears to say that Peak Games is actually doing something at the appropriate time. Now, none of this is proving the game is being played yet, but we're starting to get there. So we'd better do some digging. What the hell is this SSRM heating.log? Google SSRM_heating.log. 0 matches. Was it 0? Maybe not quite 0. It wasn't many. That much. Relatively few. Okay, this is part of a thing called the Samsung System Health Manager system. And this has nothing to do with health apps. This is about the health of the device. Turns out that what it actually is Samsung's monitor safety system. We think its original purpose was to stop devices overheating when they were being gamed too hard, basically. In particular, that the GPU was being driven too hard, and it logs things like memory usage, network usage, temperature, all of the kind of resource things that you might come across in an operating system. This thing was logging every now and then. All right. Possibly it was to do with preventing overheating. Possibly it was to do with actually tuning for games performance. We're not quite sure. What we did find out was that it received little or no attention from the academic community, certainly from academic digital forensics people. Nobody's heard of it. Very, very little documentation about it. The only place, Ethan, kudos to this one, the XDA dev community had heard of this. And that was about all we got. The rest of it, we had to work out ourselves. So what does it do? Why is it interesting? It basically logs stuff, starting on the phone's activation, and it obviously is cleared at the last factory reset. Other than that, we couldn't actually find out when the log was cleared. It makes a note of when the device has been rebooted, so it persists across sessions. And it doesn't exclusively log games. It's just logging what's going on the system. Effectively, it's kind of running top every now and then and just recording stuff about it. Format looks a lot like that. A timestamp followed by some kind of code and a message. Is it a circular buffer? Does it have a capacity limit? Does it overwrite? I don't know. I can't tell you those. That's for future work. Inevitably, it'll be a circular buffer. So stuff will persist in there for some time. I'm going to virtually guarantee one day it'll overwrite. So we managed to do some work, and we found out that it logged all of these different kinds of entries, and we did some reading and some looking through and tried to figure out things like when the LCD screen had been manipulated by set commands, logging network connections, handles the charging screen. So all kinds of interesting bits and places. That was the one we liked. Very similar to the Unix top. Logs graphic activity. Basically, what's the GPU doing and how busy is it? Okay. So after all of that, we were able to say, we can prove that something written by Peak Games, by the way, there's only one app on that phone by Peak Games, was actually active and was using the screen was on, and the GPU was busy actually processing graphics for round about the 20 minutes in question. Oh dear. So this is actually corroborating the accused's defence that the victim had been playing a game at the time of the incident, and actually, to kind of round off that bit of the story, the police went back to the complainant, and eventually she admitted the thing had been completely and utterly fabricated. She'd had a big row with the boyfriend and tried to frame him for rape. They didn't do that in the end. They were talking about possibly prosecuting her for wasting police time. They didn't in the end. As with many of these things, she probably needed mental health support rather than being arrested. So I think it kind of had a happy ending. But I think it's always interesting to remember when we do this stuff, Yeah, we love the bits and bytes. We love the technology. There are human beings on the other end of everything we do. And I think it's, for those of you who are considering a career in digital forensics, it's possibly worthwhile just bearing that particular one in mind. Okay, so that was kind of the end of the immediate involvement with the police down Bell Street. But we now had this unheard of source of evidence. The current generation of digital forensics tools know nothing about this file. We thought, well, that's a bit sad. This is quite interesting. There's useful stuff in here. How could we actually turn this into some kind of evidence-grade procedure, some kind of methodology which we could use for this? We were fortunate in that NCSC, GCHQ that year were lashing money about, and we managed to employ an intern for the summer to actually work on this and do some background work on it, which turned into rather a useful thing. I'd like to just talk about that for a few minutes now. So in terms of turning it into a DF, a digital forensics technique, what do we need to do? Again, those of you who've been in my class will know that we bang on about a digital forensics life cycle, a digital forensics process, consisting roughly of acquisition, extraction, evaluation, applicability, visualization. I may not have used exactly those words the last time you sat in CMP 209. That's the flavour of it. First of all, can we image the device? In this case, we could. Yes, we're doing nothing about decrypting phones. Wrong talk. Extraction, can you find the file? Yes, we now know where to look at it. What causes events to be logged? No idea. Oh, right, that's not really what you call forensically sound. We need to understand better what makes it actually write a log entry. How many phones actually use this Samsung System Health Monitoring software? Don't know. This one does. That's all we knew at that point. Can we make the evidence easy to comprehend? Actually, I'm going to say we failed on that one, but we can judge that later. Ethan, in his infinite wisdom, and this is pure coincidence, I assure you, actually handed me the phone this morning. He's returning it after having... What have you been doing with it for the past 3 years? I don't know. I don't want to know. I don't want to know. Factory reset. Okay. We don't have access to any 30k plus forensics tools around here. I wish we did. If anybody is now a rich alumni of this university and wishes to buy Ian a couple of copies of Encase, that'd be good. But you know me, we like open source, we like the command line. What we're going to do, well, we'll root the damn thing and run DD on it. Okay, right, we've got that. We can rooted, imaged. So now we've got a spare phone, actually identical to the one in the case, same model, same everything. We're playing with this one instead of somebody's other phone now. So that got rooted, and we started seeing what you could do to the phone, which would make it create a log entry. So once again, we were searching for relevant strings, in particular the strings that we now knew appeared in the log with BigRep, and we were able to just access the file system raw using debug.fs. If you've never used debug.fs as a way of accessing stuff on ext4 file systems and things, fun stuff. So that was kind of the before. By now, we were confident, yeah, okay, we can just mount the damn thing up and find it. A meaningless bit of Linux down the bottom. You can just grab the file off there and we can retrieve it. So key question, what causes events now to be written to the log of this phone? Well, you get money from GCHQ. What do you spend it on? You obviously spend it on hiring an intern to walk around Dundee with a mobile phone in their pocket for a few days, which is basically what Michael did. And we gave him what we called some structured walks. We came up with we wanted to go here, we wanted to spend so long there, we wanted to go within range of that Wi-Fi, we wanted to take it out, we wanted to access a web page, we wanted to do, and we came up with something that we thought kind of properly exercised all of the things that a mobile phone could do. But the point was that we needed them doing repeatedly and exactly the same time. So if you saw this guy kind of behaving really strangely around Dundee and some of the cafes in 2019, 2020, it was us. So we used a whole variety of these things, followed it, and then basically what we did was match the log entries against what we told him to do. Well, hey, presto, surprise, surprise. Every time you go past a Wi-Fi place, it logs something and says, you were at this Wi-Fi. Oh, that's quite interesting. So the phone itself is maintaining a list of which Wi-Fi access points you've been in range with. Do our privacy researchers know anything about that one? So I thought that was quite interesting. We're way back to what Apple were doing in 2012. That was a good one. Okay, so we established fairly easily, there's a pretty straightforward correspondence between common sense, everyday life events with the phone and the log file. Has that been tested in court? No. Would it stand up? I don't see why not, but maybe we need to try that one. Okay, applicability. I didn't do this, I'm making no claims, this is his department. How many phones actually have this file? What Ethan did was he grabbed the firmware, some Samsung firmware from there, of a variety of phone models, probably reverse engineered them, and confirmed that indeed the executables necessary to run the health monitoring thing were there, as was the actual log file. S6 to S9 Plus, Android 10, 7 to 10. We're guessing it's still there.
No, it's S20 Ultra is the last one. So even later than the S9 Plus.
S20 Ultra, there you are. Okay, it doesn't guarantee that it's running on any given phone, but I think the chances are pretty good. Your mileage may vary if you get to try this kind of stuff. Does that help anybody understand what was going on the phone? No. I came to this on my slides and thought, right, what shall I say about this slide and try and explain it? Actually, I could just about try. I think we could say that somehow we got from the log file that the Play Store had been accessed whenever there's a red peak, and it had probably been accessed twice. Why it's a peak rather than a bar chart, I don't know. But the physicist in me is revolting deeply against this diagram. Okay, non-labelled axes. Don't anybody ever submit a graph to me without the axes properly labelled, or you'll get a bit of 1980s Sunderland University physics person down your neck. No. We tried. We ran out of time and money. Oh my God, I'm finishing early as well here. I hope you've got some good questions. Some conclusions. 3 pages of conclusions. First of all, this thing, we think, this Samsung System Health Manager provides an interesting source of digital forensic evidence which people don't seem to know about. I really should write this up as an academic paper and publish it, but I've never got it. So this is it being presented to the world. I hope it's of use to you. We've pretty much got a validated methodology, something which has got a little bit of substance to it, which actually lets us prove that it really does what we're claiming, what it says on the tin. It's been tested to some degree at least. It hasn't been stood up in court. Is BigRep an everyday production digital forensics tool? No, absolutely isn't. It's a nasty little 4-line script. Did I do that? I did. Go back. Oh, no, it's worse than that. Actually, it's locked. Go on, get back, you little sons. Oh, no, that's interesting. I can't go back any further. Who's fiddling? Who's fiddling with my machine? You remember the last time I was here? I was talking about all of the Bluetooth snarfing stuff I was doing. There's a bunch of fourth years up there at the back. When I'm doing my live demo, suddenly start creating Bluetooth devices with rude names. Much appreciated, guys. Hang on. Why is that not? That's bizarre. Sorry about that. Is it production standard tool? No, it's not. It's a script. It's kind of handy. If you're in the game of deriving new... Right, I now know why that's doing that, and that's entirely my fault. Guess who's copied a slide from a presentation with some timing information on it. Whatever. Take Big Rep, use it. It's released under a do what you like with it license. Have fun with it. Genuinely can't remember what else I was going to say about it. I can't be bothered to go through all of that rigmarole to go back to the past slide. I suppose the point I wanted to make was, how long have I been in this game? How long have I been doing computing for? Longer than... When were you lot born? You're all millennials, aren't you? No, not quite. Not quite. Let's call it 30 years. It's actually more that I've been creating software and doing stuff with computers. I think those 4 lines of code are possibly the best 4 lines of code that I've ever written. I'm actually being deadly serious about this. I mean, I've written huge systems, but I've written stuff for my PhD with 200,000 lines of code. Actually, I think those 4 are best. I got more satisfaction from those 4 than any of the other stuff I've done. The sheer power of being able to say, just treat that file as a string, now search it. I think, if you realise what you would have to go through to do that manually, not manually, to even write the code to do that, without that mmap thing. I'm just, I'm an mmap fanboy. Go for it. Go for it. Okay. Third thing is the importance of kind of fundamentals in digital forensics. We all get excited by the latest, greatest, shiny tools. We love, the deep technical stuff that you're going to hear a whole load more about today. Don't forget your fundamentals. Don't forget that it's actually quite important that, somebody in your organisation, has that ability to go, right, timestamp, it's a number. How's it represented? It's represented like this. It'll be searched for like this. The regex was that. It's all first year stuff, second year stuff. There's nothing that difficult in anything I did here, and yet I hope it's proved that it was something that was of, genuine, real world, actual value. I encourage you. Shouldn't have thrown the pointer away. You'll have heard me bang on about this before, some of you. Deep systems knowledge, that's what this game is really about. It's about understanding what the lump of silicon in front of you is doing, how it does it, and all that kind of thing. So just to encourage you to keep on going with that sort of stuff. There's a few future things we should do. Is there equivalent functionality in other phones? I strongly suspect that Apple have something very similar to that in iOS somewhere. Is there equivalent functionality in other Samsung devices? I've got a Samsung Smart TV at home. Is it sneakily monitoring when I turn it on? Don't know. Anybody wants to buy me another big Samsung? I'll quite happily take it apart and have a look. Just simply trying that technique on other devices, on IoT forensics. Got a couple of PhD folks at the moment working on doing forensic investigation of IoT devices. Maybe actually going in at that low level and looking for stuff like that might be an interesting thing for us to try. So some future work to have a go at there. Very finally, a couple of thanks really. First of all to DCI Mark Lorente from Tayside Police Scotland, for having the faith in us to just walk along the road, bang on the door and say, can you do anything with this? Without that, none of this would have happened. It doesn't happen often that somebody just lands on the door and says, here's an interesting problem, but when it does, it's kind of one of those really nice moments of your career. And also a big thanks to Michael, our summer intern, who did a lot of the hard graft of actually turning some fairly nebulous ideas and some hacking around with Python into a properly validated methodology. If you want Big Rep, it's there. I promise I'm not rickrolling you much with that. I don't need to rickroll you, I've rickrolled myself. Oh, God. There you go. Right, that's the end. Any questions? No, go on, first.
Did you reach out to Samsung when they knew what the file was?
I think we tried. I think we got absolutely nowhere. I think that mind you, I simply don't have the contacts in Samsung. I think we were at the stage of digging a couple of email addresses off the Samsung website and just emailing them speculatively. I don't actually know anybody who works. Do we have anybody from Samsung in this morning? And if they do, they're not admitting to it. They're furiously ringing, saying, "What the hell's this system monitoring thing?" No. So no. Short answer: we tried, but no.
What's the maximum size of the file you can import from Bigraph?
The maximum size of the file you can process with Bigraph will be limited by a 64-bit pointer. So 2 to the power 64 bytes. Anybody wants to work that out? Nick wants to know over there. I don't hold the number in my mind. It's big. 2 to the 64 is big.
Seeing as the logs are taken at regular intervals, if someone were to try and erase that information, would it be obvious that it's like a gap, or would it just kind of not be able to prove that they're covering up?
I think if you deleted one line out of it, the chances are you're not going to notice. I think if you delete 20 minutes worth out of it, you're going to spot it. Because the phone's actually... Sorry, I should be up here for the microphones. The phone is constantly logging things and doing things, even when it's sitting by your bedside at night and you're not touching it. It's automatic updates and God knows what else it's doing. And that kind of thing is logged. So I think you would notice it in those circumstances. Okay, so the question is, how did we come up with the structured walk that we set them doing? Basically, we cheated. So we did a couple of rough ones and just looked to see what was in there, and we started seeing things like Wi-Fi equals Starbucks. Okay, URL this at this time, and you kind of figured, well, okay, what we need to do is to do all of the kind of systemy things which are kind of built into the raw operating system, so like networking things, like doing an update, that kind of thing. So they all got incorporated. And then it was a question of looking at, well, let's consider the kind of apps that somebody has on their phone. Is there a typical app? Well, everybody's got a browser. Everybody's got Facebook, don't they? TikTok? I don't know. So, we just picked a few. And, I think I'm going to stand up and say that's the limit of the rigor of the thing. Really, what else can you do? It's got to be your imagination about what can this phone do. If you do it to the phone, does anything appear in the log? And some things did, some things didn't. But by and large, the kind of things that you might expect it to log, there was an entry there sometimes. Even sometimes it's just, okay, how busy is the processor? At that particular point, there's a spike in the stuff that top returns, and you see, okay, it was busy at that point. Screen on, screen off, backlight on, backlight off. You can see other bits of hardware on the phone. I think I can't honestly remember. Did we check for the Bluetooth being turned on and off? That kind of thing. It was looking at what is the hardware capable of, what might it be used for, is there an entry for it? Make it up on the spur of the moment. Any more for any more? Oh, you've got a follow-up question. Go on. Well, yeah. No, that's a fair question. How do you keep a forensic methodology up to date, kind of thing? The answer is that you write it at a suitably abstract level. If your methodology is, press this button, enter the number 2, scroll down twice, that's going to be out of date in 6 months. If it is point 1, understand the hardware in the device from whatever source. Point 2, understand the inputs and outputs to this system. Point 3, find a way of capturing those inputs. And if you write at a suitably abstract level, then its survivability is longer. I reckon you can write a digital forensics methodology. Again, one of the points that I bang on continually about to the students here is, what's that? See if any of them have been listening. What is it? Somebody said it. It's a computer. Okay, so all of the stuff that we've been doing with computer forensics and digital forensics for the past 20 years is precisely applicable to this. It's got input devices. It's got storage. It's got all of the things that your desktop computer has got. Don't treat it any differently. And if your methodology is written sufficiently abstractly to cope with that level, I've got one of the PhD guys at the moment is doing stuff on IoT forensics, and I've said it needs to come up with a methodology. What I'm looking for in that methodology is not connect a USB connected to that. It's one, go away and understand the hardware on the device you're doing it from. Whether that's from the manual, whether it's via internet search, try and find out about the device first. Second stage, okay, now you can take it apart and have a look and see what's in there. Can you identify the storage device? That black thing there, that looks like a chip. All right. Is it a processor chip? Is it a NAND flash chip? Is it a storage chip? Is it a whatever chip? All right. And you can write your methodology such that it can cope with that kind of thing. And that, I think, stands a chance of surviving for a while. Admittedly, yeah, there is a problem. Technology changes. We've got to live with it. How am I doing? Oh, another 10 minutes. Oh my god! Shall I sing a song? Yeah. No, you really don't. Some of you may remember that we used to do lectures in room 3006, which has the piano at the front. That was always good for a giggle when we ran out of material. Right, sorry, there was another one. Yes, sir.
So I know you said that, for example, in this case, you're looking for an app about a specific type, but there's lots of different types of items.
Mm-hmm. Mm-hmm.
How much of that, because you've got from generic Android system logs, other tools you can manually or automatically, how much was completely brand new, I never knew you could see this along before?
That's a very good question. I can't give you a straight answer to that one. I think the answer is probably quite a lot, but it was just the one that really caught our eye was this top thing. And the fact that it identified how much resource certain processes were using. And that, as far as we know. So even when you've got an app like this game, which frankly doesn't do very much, it's still appearing in the log. It never logs anything explicitly itself, but because this is being monitored, it appeared there, and that seemed like a useful source of information. So I can't give you a percentage. It's probably something that should be done. Anybody wants to find me a project? Cross-check the heat log against some of the other sources. That would be an interesting thing to validate that way. Yeah.
I was also probably asking back that. How long after that type was the device image? Or just, you said memory buffer, obviously a lot of things.
It was within a couple of days, but what we did observe was that the log went back months.
Yeah.
So it obviously been quite a while since the log had cycled over. It certainly persists through. As far as we can tell, the only thing that it doesn't persist through is a factory reset. Any more for any more? Oh, yes, sir. That's a good question. How long? Real time, probably about 6 weeks from first getting the phone to actually being able to go back to the police with some confidence and say, yeah, we know that game was being played at that time. That wasn't 6 weeks, me working on it full time. Universities don't work like that kind of thing. But of that order.
Yes, I've got two small things. The first one is, did you have to run the game and analyze the to kind of gather or gain an understanding of what that resource looked like for the game being idle and actively played?
We certainly did, but that was kind of more in the kind of deeper understanding methodological stage when we were actually still talking to the police live. I was very conscious that this was a live investigation, basically, as soon as we had a couple of entries in the log which said, look, this phone has been busy with this game in this period, they were very keen on hearing that early.
And then I guess the second part of it is, for this to be like something that's widely used, do you think, maybe you have that understanding already, but do we need to understand enough about the system health monitoring to draw conclusions? For example, if there's an absence of entries, we know enough about what causes entries to be written to say the game wasn't played or it's probably a generic question.
It's a reasonable question. Well, it's a philosophical question. Can you prove an absence of evidence? What does it say? In the end, not a lot. All you can do sometimes is say, look, we have indications that something was going on here, and that feeds back into the real life investigation. I mean, what happened here was, as soon as we had some indication that something was going on, they went back to the person and said, hang on, your story doesn't quite stack up here. And actually, it was admitted relatively easily. In terms of the kind of rigour that you're talking about, yes, there is more work to be done, and I'm not going to hide that fact. Paul?
You mentioned that you were the third choice for this.
Yeah.
Is there a sort of feedback back with you about second choice and say this is what we found, this is where you guys really found it?
In a sense, this is it. What I should do is write a proper paper and publish it in Digital Investigations. And I've sat down and started to write that paper about 3 times. You think you students are good at avoiding deadlines and procrastination? Master. So, I mean, yeah, the proper thing to do. Now that I've actually... You may find that you folks have been very useful in that you've forced me to think about this again. Maybe I should now sit down and actually write that paper. That would go into digital forensics. That is read in the labs, and that is certainly read by the people who make the software. So that's kind of the way of feeding back into it. So yeah, that'll be how it goes. 2 minutes? You want to keep going for another 2 minutes? Okay, go on. Anybody got anything else, or are you all running away? Go on, yes sir. I think there are actually multiple entries in one line, and I think it's a lot of them. I can't, you've got me. Can't remember off the top of my head, but there was multiple things: processor, core, GPU, and a couple of other bits and pieces as well. Right, I am actually going to shut up at that point and let you get off to the next talk. Thank you.